Okay, now we're ready to look at the process for solving trigonometric equations. And we're just going to look at a couple of examples to kind of get a feel for the process. We'll start off with the basic one, 2 sine theta minus 1 equals 0. Now what you want to do first of all, typically, is you want to treat the trig function as though it were a variable and just solve the equation for that variable. In other words, I'm going to solve this equation as though it were 2x minus 1 equals 0. So you start off by adding 1 to both sides, and you now have 2 sine theta equals 1. Divide out the 2, and we have sine theta equals 1/2. Now, the question is, once we have that equation or that function solved, we can now ask ourselves, well, where does sine theta equal 1/2? In other words, the sine of what angle is 1/2? Well, let's refer to the unit circle. And remember that on the unit circle there are two places for one trip around the unit circle where sine theta is 1/2. Remember, it's the y-coordinates. Sine has there's a y-coordinate of 1/2 at two places, and that is where the angle is pi over 6 and 5 pi over 6. So in other words, in the first and in the second quadrant, you have an ordered pair in which the y-coordinate is 1/2. So in other words, these are solutions. Sine of pi over 6 is 1/2, so that's definitely a solution. And sine of 5 pi over 6 is equal to 1/2. So both of those angles are solutions to this equation. So we have theta equals pi over 6 or theta equals 5 pi over 6. Now, notice that these angles, this pi over 6 and this 5 pi over 6, have many coterminal angles. And that's what we want to explore next, because there are actually more angles that will yield solutions to this sine theta equals 1/2 than just pi over 6 and 5 pi over 6. We must be able to list all the coterminal angles. So we've got pi over 6 and 5 pi over 6. Now let's take a look at all those angles that are coterminal, because the coterminal angles will also give us sine of theta equals 1/2. So let's take a look. We've got the two solutions that we've already identified, the pi over 6 and the 5 pi over 6. Now, let's just consider this pi over 6 first of all. We'll just take a look at this one, and then we'll take what we've said about pi over 6 and relate it to the 5 pi over 6. Now, we've said that theta equals pi over 6 is a solution. Well, what if we do this? What if we go one time around the circle and land right back at this same point so that we're at a coterminal angle, so that we're at an angle coterminal to pi over 6? Well, that angle is pi over 6 plus 2 pi. So we would conclude that pi over 6 is a solution, and pi over 6 plus 2 pi is also a solution. Now, let's go around again. Once again, we've gone around twice, and we're right back at this angle, at an angle coterminal to pi over 6, and we could call that theta equals pi over 6 plus 2 times 2 pi. So notice, pi over 6 plus 2 pi, and pi over 6 plus 2 times 2 pi. Now let's go around again. And once again, we generated another coterminal angle by going 3 times around. So here we're at pi over 6. Here we go once around, twice around, and 3 times. So you can see how that we could continue this process endlessly. We could continue to go around the circle and visit these coterminal angles. And not just, this way we're going around counterclockwise, getting all the angles that are coterminal. We could also generate an infinite number going around clockwise by subtracting off multiples of 2 pi. So what we could do is just say, well, theta equals pi over 6 plus 2k pi. and identify k as just an integer. We can do the same thing for 5 pi over 6. So we could say, okay, the solution in general is going to be pi over 6 plus 2k pi, or 5 pi over 6 plus 2k pi, where k is an integer. And that's how we would write our final solution. Now, let's move up the level of difficulty just a little bit and look at 4 cosine squared 2 theta minus 3. Well, first of all, of course, we're going to solve for the cosine. So I need to add 3 to both sides. Then I'll divide out the 4. And now, of course, we take the square root because we have cosine squared 2 theta equals 3/4, which gives us cosine 2 theta equals plus or minus the square root of 3 over 2. Now, same process. We look at the unit circle and identify places on the unit circle where the x-coordinate is plus or minus the square root of 3 over 2. And we've identified these places: pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So let's see what we have. Okay. First of all, now notice I'm solving for 2 theta. Before I'm finished, we'll have just a single value of theta. We'll have 1 theta, the solution for 1 theta. But right now, I'm just going to take whatever's in here, in this case 2 theta, and solve for that. So I'm solving for 2 theta instead of just for theta at first. So notice, we get 2 theta equals pi over 6 plus 2k pi. That's the general solution for this one, pi over 6. Or 2 theta equals 7 pi over 6 plus 2k pi. And that corresponds to this quadrant 3 angle. So we've got quadrant 1 angle and the quadrant 3 angle. You may be wondering, well, why did I do that? Why didn't I go quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Well, I identified the solution in quadrant 1 and quadrant 3 because notice that if I'm at pi over 6 and I add pi, I arrive at that 7 pi over 6. And then if I'm at 7 pi over 6, I add pi, I get right back up here to this angle again. So it looks like by adding pi each time, I go from one angle to the other. I go from angles that are coterminal to pi over 6 to angles that are coterminal to 7 pi over 6 by just adding a pi each time. So we could combine those two solutions and just say, well, 2 theta equals pi over 6 plus k pi. And of course, k is an integer. Now, let's do the same thing for this 5 pi over 6 and 11 pi over 6. So I'm saying that 2 theta equals 5 pi over 6 plus 2k pi, or 2 theta equals 11 pi over 6 plus 2k pi. And I combine those in a similar fashion as before. And now I have that 2 theta equals 5 pi over 6 plus k pi. Now, this is not the solution that I want. This is not the solution set because what I'm wanting to do is solve for theta. But what I've in fact done is solve for 2 theta. Well, that can be remedied just by dividing through by the 2. And I get theta equals pi over 12 plus pi over 2k. And for the other one, theta equals 5 pi over 12 plus pi over 2k. And once again, k is an integer.